In today's video, we're going to walk through the new ServiceStack Commands feature plugin. This plugin enables the ability to easily configure and manage background jobs that comes with a built-in UI for monitoring that's integrated into the existing admin UIs. There are many ways to orchestrate longer-running async tasks within .NET, but commonly observability of these tasks is missing or requires additional infrastructure to get working. The ServiceStack Commands feature plugin enables a simple and familiar way of creating long-running tasks which take a simple POCO class as input and provides built-in admin UIs to see errors, runtime statistics, as well as the ability to explore available commands to trigger to run in your system. Commands are ideal for tasks that you don't want to run in your request pipeline, but where you also don't want such a system to dictate the needs for additional infrastructure. Commands can be orchestrated together into workflows by commands firing downstream commands that you can chain and reuse with different workflows. Additionally, this admin UI also shows API calls, so you can now monitor specific API calls for errors, as well as possible performance issues, as additional functionality from the Commands feature plugin now supports API calls. Today we'll be creating a new Blazor View application which already has the Commands feature plugin enabled in the template by default. We can create our own custom commands, and we will explore the updated admin UI to show you how you can get the most out of these new features. We can create a new solution using the ServiceStack website and the Getting Started page, or the ServiceStack.NET X tool using the command xnew blazor-view myapp. Using the X tool will automatically initialize our project so it's ready to use, whereas if you are downloading a generated solution from the Getting Started page, remember to use npm run migrate to initialize your database schema. Opening the solution with your preferred .NET IDE, and we will see the familiar for-project setup of app host, service interface, service model, and tests. Running our application without any changes, and we will have a working Blazor View application where we can then navigate to /admin-UI and log in with the example admin user. Here we will see a new menu on the left-hand side called Commands. Opening the Commands admin UI, we will be greeted with a summary page along with the Explore, Latest, and Errors tab at the top. The summary page will already have some entries in it, and this is because by default, it will also show API usage as well. Clicking on any of these entries will also get you a graph showing you timings of the calls in milliseconds, with the average and median highlighted differently to make any possible performance issues a bit more obvious. Last, errors are also shown in the summary, and here we have an unauthorized error which occurred before we logged in as the example admin user, which then returned a 401. Currently, the Explore tab doesn't have any entries as our project doesn't have any commands configured. The latest will show an ordered list of API calls and commands where we can clearly see the type on the left-hand side. Currently, they are all API entries as well. On the Errors tab, we can see our 401 error, which we can then open for more details. Going back to our solution, we can create custom commands by implementing the IAsync command interface. This has a single method of execute async of type T to implement, where T is the type of your command request or input. Just like how you implement ServiceStack services with an input request DTO class, commands use that simple POCO to pass data to be used during execution. The isolated unit of logic lives in the execute async method, which is the only implementation required for the IAsync command interface. Commands also have no return type since they are async by default and are designed to be used in a fire and forget manner. However, there is also a second IAsync command interface which takes a second type parameter This is used to specify the type of the result property of your command class. This can be used to pass a payload back to the admin UI to present on the completion of your command. Let's walk through another command use case, one you might find in a line of business application. For example, if we had to generate a complex report, we might create a class called report command, implementing the IAsync command interface where T was a POCO called generate report. This might take a date range which would be used to fetch and process data from various sources. We will use an await tasks.delay 10,000 to simulate the long-running task and then rerun our application. Navigating back to /admin-UI and selecting commands from the left-hand menu, we can now click on the Explore tab to see the report commands come up under Other. Here, Other is just the default tag if a tag attribute is not used on the command class itself. Just like how the tag attribute can be used to organize your services in the API Explorer interface, tags can be used to do the same for commands as well in this Explore tab. Selecting the report command and we will see a generated form for populating the generate report POCO and firing the command. If we stay on this screen, we will get a notification of its completion, but we can also navigate away and monitor the summary page to see the runtime stats and if the command completed with an error or successfully. If we always wanted to show some kind of result in the admin UI for the report command, we would add an additional type parameter onto the IAsync command interface. This would force the use of the result property, which we would then populate in our execute async method. Another useful feature built into commands is retries. Retry strategies are built in with 5 different types of behavior which can be configured in the plugin using the default retry policy when you configure the plugin itself. In the Blazor View template, the commands feature plugin is instantiated in the configure.mq.cs file. This lets us control various options, including the default behavior for any command that uses the retry attribute. This lets you use features like linear, exponential, and full jitter backoff via simple configuration and override as needed using the retry attribute. Also in the plugin configuration, you can control which roles have access to the command features APIs, as well as commands to ignore, among other options. If we want to string or chain together several commands into a workflow, we can inject the iCommand executor into any of our command classes. For example, if we create a bulk reports class implementing the IAsync command interface, we can use the iCommand executor to then fire multiple of the report command, passing in different values for the report command's execute async method. This setup will fire each report command sequentially using the same thread. However, if you wanted to run them in parallel, you could swap out the iCommand executor for a message queue implementation to orchestrate firing additional commands. This approach of firing off subsequent commands enables us to build workflows, maximizing the reuse of the code we've written for our commands. Notice how we're using the iCommand executor as a default constructor argument, meaning that it's getting injected from our IOC. So these commands are single isolated units of logic that have auto-wired dependencies, making it easier to extend and expand the use of commands and linking them together to create workflows. Commands are auto-wired and encapsulated pieces of logic that can become testable internal APIs. They aren't exposed as services, but through the Explore Commands admin UI, we can fire them and reuse them as needed. By default, commands have a lifetime that is transient, similar to how service classes are used. However, we can change this by altering the lifetime attribute, which enables us to manage different scopes Or you can control how your commands are registered by registering them yourself in IOC rather than relying on assembly scanning. Retry policies are also overridable. We can attribute our custom commands with the retry attribute specifying different options that are just for this command, overriding the default that you have provided to the commands feature plugin in your app host. If you want to explore more concrete examples of using commands widely in your application, you can check out our AI server or pvq.app applications, which use them heavily to get the most out of running a simple SQLite powered application and avoiding issues with thread locking due to SQLite's limitation of having a single threaded writer. For example, the PVQ app uses 5 separate SQLite databases for different responsibilities, and we can use ServiceStack commands to dedicate a single thread to writing to each database. This gives us high performance while maintaining a minimal resource footprint for the application. In the AI server application, we also use it for notifications to the user, longer running interactions with LLM APIs, and more. The ServiceStack commands feature plugin provides a simple yet powerful way to have background jobs you can observe and monitor with built-in admin UIs without any additional infrastructure imposed on you. This enables a huge amount of flexibility since you can use it standalone in a SQLite powered application or extend it yourself to use existing infrastructure on a command by command basis. Well, that's it for this video. If you have any questions or feedback, let us know in the comments below, or you can join us on our community Discord or GitHub discussions. ServiceStack is free for individuals, so anyone is welcome. And as always, thanks for watching.